Yes, we're still in alkanols, and we said we don't want to call them alkanols, we call them alcohols, and they are derivatives of alkanes. So we have so far looked at the general formula, functional group, the examples. We have also looked at laboratory preparations through the fermentation process. We have seen how we can produce ethanol in the lab, and also we have looked at the three classes of alcohols and how we can distinguish the different type when we are in the lab for practicals. So now we are going to look at the properties of ethanol, and in the properties of ethanol we are going to see the physical properties. After seeing the physical properties, we shall look at the chemical properties, where our focus will be here, much of our focus will be here. Then at the same time we shall look at what we call the compactions. Then we look at dehydration, esterification. So those are the classified as the chemical properties. Then after that, we shall look at the reducing properties of ethanol. So when we say reducing properties of ethanol, that means ethanol become the what? The reducing agents, and in the process is going to be oxidized. Then we shall conclude our lessons for alcohols with the uses of ethanols. So now let's look at the physical properties of ethanol. Physical properties of ethanol. So ethanols, we even know ethanols. We get to interact with it and we see it. So when you look at it, it is colorless. So that means it has no what? It has no color. So it is colorless. That's one thing we should need to know about it. But also, this one has what we call the characteristic smell. There's that smell is being described as characteristic smell. When you smell alcohol, there is that feelings. So it is described as characteristic smells. But also when you look at it, boiling point, this is very, very, very important. The boiling point is at 78 degrees Celsius. So that's the boiling point of alcohol. So that means when you're boiling alcohol together with water is 100 degrees Celsius. So that means alcohol will reach its boiling point faster compared to water. Then after that, we shall also look at its solubility. We can say it is soluble in water. So that means if this is the test tube, of course we assume we're in the lab, and then I have water in the test tube. This is water, and then also poured on top what we call the ethanol. They are going to form what we call miscible mixtures. So that means you're not going to distinguish between the layers. You cannot say this layer is for ethanol, this layer is for what? For water. Unlike if you mix water with oil, like cooking oils, you'll be in position to see that the different layers being formed. So for this, we are saying ethanol is soluble in water. I mean, it is not a solvent, but it is soluble in water. Soluble in water. So these are the physical properties that we look at when we are dealing with ethanol. Now let's go to the chemical properties. So that means this become our number one. We shall have our number two, chemical properties. So when we talk about chemical properties, we want to see the behaviors of this ethanol when it is subjected to heat, when it is subjected to when they are mixed or combined or reacted with other compounds, how do it behave? So those are the chemical properties. And we said part A is what we call the compositions. So we have number 2, the chemical properties of ethanol. So we said part A is the compositions. So if I have my ethanol, which is CH3, CH2, OH, I burn it in oxygen. Oxygen is a gas. Ethanol can be a liquid. You can put the chemical formula, the state symbol, or you can leave it that way. So here I'll be in position to produce carbon dioxide, gas, and water, liquid. So like this, we are saying ethanol burns in oxygen with the blue flame. So when you're in the lab, you'll be in position to see that blue flame come out of that test tube when you're burning it. So blue flamed to form carbon dioxide and water. And you can simply balance these equations in this format. Put 3 here, this time this 6. I'll put 2 here to make carbon 2. So if I'm done with carbon, I go to hydrogen. I'll have 3 plus 2 plus this 6. This time this 6. Oxygen 3 plus this time this 4, 7. 3 times 2, 6 plus this 7. So this is the equations for the combustion of ethanol. And we need to know the color. When you are burning it, it is blue flame. You see it's coming up like that. So if we are done with combustion, so let's go to what we call the dehydration. Or you can say dehydration of ethanol. So this thing will take us back to the knowledge of ethane. So when we alkenes, when we were preparing ethanes, we say that when I have my alcohol, when I have the alcohol, which is ethanol mainly, and in presence of concentrated, which is corn sulfuric acid at 180 degrees Celsius, this temperature is very important, I'll be in position to produce ethane, which is a gas, plus some molecules of water being given out. So this is the hydrating properties of ethanols. So it can be dehydrated in presence of this and that temperature to produce for us what we call ethane gas and water. So this equation we have gotten it in alkenes when we are preparing ethane gas. Okay, let's look at C, which is esterification. Esterifications, this is the reaction between alcohols and alkanoic acids, of which we are going to talk about them. We call them sometimes carboxylic acid. We shall be in position to see them in detail. But here we're saying during esterification, what happens is that if I have my ethanol, CH3, OH, plus, let's say I have my carboxylic acid, which is methanoic acid, When I combine this thing together, I'll be in position to get CH3, CH2, COOCH3, plus water molecules being formed. So this is what we call esterification reaction. And this reaction result into the formation of sweet fruity smell. So when you're in the lab, you'll be in position to smell this when you combine uh, ethanol and what we call the carboxylic acid. And this happens in presence of corn sulfuric acid, and then you heat. You'll be in position to get the esters being formed. So this is all about the esterification reaction. So let's look at this last part where we say the reducing properties of ethanol. So when I say reducing properties of ethanols, what will come in our mind is that ethanol itself is what? Is a strong reducing agent. So we shall say it, reducing properties of ethanol. So therefore, it is going to reduce two powerful oxidizing agents, and those two powerful oxidizing agents are, we have what we call acidified. When I say acidified, that means I've added acidified potassium dichromate 6. That is 1. 2, we shall have acidified potassium manganate 7. So after us seeing that, if you don't want to call it like that, you can say acidified potassium manganate. So now what do we need to know? If you are treating this one with ethanol, we shall be in position to at least focus on the colors. So for acidified potassium dichromate 6, it is orange in color. So when it is treated with ethanols together, the color will turn to green. That is very, very important. But also, what if I'm using acidified potassium permanganate? Here, the color is purple. And then, when it is treated with ethanol, the color will turn colorless. And the whole process takes place on warming. So that means you treat these oxidizing agents with ethanol in presence of warming. We shall be in position to see these changes of colors. So we have for acidified potassium dichromate 6, the orange solution turns green. Then for acidified potassium permanganate or potassium manganate 7, the purple solution turns colorless. And this happens on warming.